Java's Genesis sequence.
Hello, everyone. I'm Fabio, this is Thomas, and we're super excited to show you something fun that you can do in Java.
Yeah, so we all love Java, right? We know how to program in Java, and we use it often. But what if you could not only use Java for your application, but you can use Python additionally, you can use JavaScript, and maybe even something compiled to WebAssembly. Now, when you think about that, that sounds kind of interesting at first, but maybe one of your colleagues is going like, why the hell would you want to do that? Because it might also sound a little bit crazy to some people. So now, the main reason for that is, well, Java itself does have a very rich ecosystem. That's true. We have Maven Central. There's many packages on Maven Central. But over the years now, also other languages have built up library ecosystems that are quite valuable. And what if in your application you could not only use a library from Maven Central, but maybe for the task you currently have, there is an interesting library on the Python package index, or there's an interesting library in the npm registry that you want to leverage for your application. And that could be a reason for you to combine here multiple languages in the same project. And to solve that, we have a technology that we are working on in open source already for many years. But what's new since the last GraalVM release is that these technologies are now considered production ready. And these technologies are called GraalPy for Python execution, GraalJS for JavaScript execution, and GraalVM for executing WebAssembly bytecodes. And in this way, support any language that can compile to WebAssembly, which includes Rust and C, C++, and so on. Now, those languages are all self-contained, and they have no extra dependencies that are drawn in when you use them. And while they are maintained in open source by the GraalVM team, they can run on any OpenJDK distribution. So this is very important to note. While, of course, as a Graal team members, we like Graal, but if you want this technology, you don't have to use Graal with it. You can use it on any OpenJDK distribution. Of course, it performs best on the Graal compiler, and it uses the Graal JIT compiler and Truffle and its compilation techniques to make the languages very fast. But also on a regular OpenJDK, it will run those languages in interpreter mode and work well. Those language implementations are also compatible with GraalVM native image. So if you want to make a native image out of your Java application, you can embed these language runtimes in the image. That can be an advantage for you also in terms of deploying this, because everything gets deployed in this case in a single binary executable. So one of the things is, if you're an IntelliJ user, which is a really cool IDE, by the way, you are already using GraalJS, because since the last release of IntelliJ, they're using GraalJS for the execution engine of the HTTP client. So specifically, the JavaScript part of this is already in production in many other projects, both at Oracle, but also externally, in this case, at IntelliJ. And in order to use those languages, it's really as simple as using any other Java library. You have to put a Maven dependency on the polyglot package of Graal, and then you add a Maven dependency on the specific language that you want to use. And once you do that, you get an API for running these languages and for integrating them into your application. And to show a little bit what you can do with this, we are now getting into the part where we show you a bunch of risky live demos. And for this, I have Fabio with me, who will guide us through that.
Right. So if you want to check out GraalPy, you go to the GraalVM website and you choose the GraalPy project, and that gives you this landing page. You find a bunch of the things that we're talking about today on this page, including the starter, right? So this is the Maven snippet that you need, or the Gradle snippet that you need, and then this is the code that you can run, right? So let's take that for a quick spin. So here's the code. I already copied it over. This creates a new context using this polyglot API, and then in that context, I can say evaluate Python code, and that's a print hello from GraalPy. So if I run this, running it here on Java 23 Graal, the latest GraalVM release, then I get hello from GraalPy, right? So what does my POM XML look like? Well, this is a template I generated with the Maven archetype. I added the version here that I want to use. All of the versions that I want to use for Polyglot and Python and JavaScript, they need to be the same, they need to match. And then here is the dependency on the Polyglot package. And further down is the dependency on GraalPy. This is actually a POM dependency. It will provide runtime dependencies, including many Python GraalPy jars. That's all handled for you. Maybe in the future we can even get it down to just one dependency. But that's what I needed to do to make this demo work. So if we're here, we can just switch to this, which is, by the way, the starter for JavaScript, right? So this has changed evaluate to JavaScript, and now we do console log hello from Graal.js. So if you're on our website and you're navigating to JavaScript right here, then this looks awkwardly familiar because it works the same way. Right? The only difference is the runtime dependency is now on JavaScript and not on Python. You can have both, which is what I'm actually doing here in this starter. So let me run this. This is hello.js. And this is using the Maven exec command. The main is hello.js without any arguments. And here is hello from Graal.js, right? So this is really simple. This allows me to evaluate pure JavaScript and pure Python code.
Right. I mean, this is just to get you started at the dependency. I mean, printing hello world also works pretty good in Java.
Yes.
So maybe let's get to something.
Yes, let's get to something more exciting. So a lot of people are excited about the stuff that the guys at OpenAI are doing, right? And the OpenAI team, unfortunately, does not provide an SDK in Java, right? So if you want to use their latest SDK, they give you a node or they give you a Python package. This is the Python package. So let's take that for a spin, right? Well, like, of course, this is a REST API, so a bunch of people have already ported this to Java, and you can use a Java library to talk to that API. But the moment the port is done, the Python world has already moved on, right? And there's new features that you want, and you're missing out, right? So let's just try and see what that feels like if I want to use this in my Java application. So going back to this example, I've extended it, I've pasted in the code, and I've adjusted it a little bit. So first I do like get my user input, so depending on like my arguments, and then I create a context. This time I'm using this utility. We get to that. It's not too important, but this is essentially the thing that connects my Java app with the virtual environment in Python, which contains Python packages, because we need to install a Python package, right? So then, from here on, I evaluate Python code, and now I'm making full use of my great IDE, which supports language injection. So by saying this, I get auto-completion, documentation, everything, right, in IntelliJ.
Yes,
so
that's why IntelliJ is an awesome IDE.
Yes, it's really cool. So this is the example snippet from their website. We can check. So like, yeah, you create this chat completion thing and you say something. I turned that into a little Python function that takes user input and then uses that as a for content. But then we return the Python function, right? And here comes our value API into play, which is in this polyglot package. You can say I want this Python object, which is the last line of the snippet, is the return value, and I want this as a create chat completion function class. So if I look at that class, there's actually a functional interface consuming a string, which is my choice, and then it returns a chat completion. So what I've done here is I've ported the the OpenAI interface to Java in the right way. You just look at the Python code and you take what you need. In the future, we'll make that easier too, but this is what I needed to make this example work. So then I have a handle on a create chat completion function, and then I can apply my user input to it, iterate through the choices, and print the messages, right? So let me run that demo. We are now using OpenAI, and we want something like, what is GraalPy? So this will take a little bit longer. So Maven exec, OpenAI, what is GraalPy? Right, and now it also needs to load the Python code, it needs to load a Python extension, and then it calls out to the REST API, and eventually we should get a result if
and then OpenAI needs to think, right?
Yeah, OpenAI needs to think. They will need to charge my credit card, and then we should get a result. So here's the result. GraalPy is an implementation of Python on the GraalVM platform. GraalVM is a high-performance virtual machine that supports multiple languages and can run applications written in different programming languages. GraalPy uses the Graal compiler to optimize Python code for better performance and so on. Interoperability.
It's okay. It could be better. But
yeah, it could be better. We're working on it.
Maybe after this talk, they will get better.
Yes. So now the question is, how did I install the OpenAI package? Well, let's take a look at my POM.
Right,
so,
yeah, exactly. How do you specify that?
Yeah, so what I've added is this additional dependency, which provides me with the helper that connects my context with the Python world. And then I use the GraalPy Maven plugin, which is here. So this is the GraalPy Maven plugin. And here I have specified all the dependencies, transitive dependencies of my OpenAI package. Well, I'm a Java developer, right?
Welcome to Maven, the polyglot package manager that can also get your Python packages.
Right. I could have just put OpenAI in here without a version, and then it would have given me the latest version, but also pip supports version ranges, so the version that I actually get is dependent on when I build the app, right? So, and I don't like that as a Java developer. I want all my versions to be well defined. So I recommend you do this, right? There's pip freeze that freezes all your Python dependencies. That's what I've used. I pasted it in here and made it look like XML, and off I go, right?
Yeah, and this is Maven, right? But we are already talking with the Gradle
people. Yes. Next week we are launching the GraalPy Gradle plugin with the next CPU release, and then you will be able to do the same way, maybe without the XML and maybe a bit shorter, but in Gradle, right? And yeah, we're totally looking forward to that.
Yes, but this is one file now specifying your Python dependencies and your Java dependencies.
Yes. And in the background, when you run the package command or any Maven command that processes the application, it will create a virtual file system, which contains then a virtual environment. That's a Python concept, and in here are the packages installed. So you don't need to take care of this. This will be bundled into your jars, and you will be able to run it just like any other Java application. And you can also compile it to a native image, with native image, into an executable, and that's all been taken care of by the plugins and by GraalPy. Okay, so let's move on to something else.
Maybe something visual, right?
Yeah, something visual. So Python is great for visualizing data and for visualizing stuff. So this is a pure Python charting library that can render interactive SVGs. That's kind of neat. So let's take that for a spin. Let's take a look at maybe the XY example. So this is an interactive XY chart, right? And all I need to do is write something like this in Python, and off I go. So why don't we turn this into a microservice, right? So here's my application. It's already running. So this is the Python endpoint. If I change this to mixed, I get the same result. If I change it to Java, I get the same result, right? So actually, I've written a test that makes sure that the results are all identical, because it's not interesting what you see here, but it's interesting how this is implemented, right? So let's take a quick look. what that looks like. This is a Spring Boot application. So here's my demo controller. And by the way, all the demos that we're showing up on GitHub, we'll show the link later. You will see the link in a couple of minutes. And you can take this for a test drive yourself, right? So this demo controller has 4 different services. They're all implementing render XY chart, and each of them serves a different endpoint. And they're all implemented slightly different. Right, so the pure Python version looks like this. I just copied over the whole example, and because I don't want to do this on every request, it's always the same result. I'll just put this into the constructor of the service and ask for the result to be returned as a string, because I know that this is a string. Again, language injections, auto-completion, everything from IntelliJ, and then I just return the Java string. Right, so that's the service. Like if I want everything in Python, I can do that, right? But typically you would want to do something mixed, right? So you would want to do something where your data is Java data, like a Java string, or a list of entries, and the entries are Java records, right? So you could do that. So this is the same data, if you will, but in Java. And then we're calling a Python function with the title and the data point. So let's take a look how that function works. Well, the function is defined here. Same thing, language injection, PyGraal, define a function. This looks awkwardly familiar to the OpenAI example, right? So I set up a new XY chart, set the title, iterate through the list. These are the records, right? So this doesn't look like Python code. I did that on purpose so that you see this is actually a Java object. Right, we add the data, and then we render everything, and we return the function. And because it's a function, we can declare a render XY function, functional interface, and don't program against like a value or some Python function, but program against a proper Java interface. So that yields the same result. We can also quickly look at the pure Java implementation. So here I've just ported more of the interface that I actually need, and I import the PyGraal module as the PyGraal interface.
Right. I mean, it's not pure Java. It's still calling the Python package, but it's moving more of the logic to Java. And I think what we're demonstrating here is like you can choose at what point you want to make the switch from your Java universe to your Python universe. You want the data on one side, other side mixed. This works all very well, and thanks to the nice IDE integration, it's also a good developer experience as you develop your app here in a mixed way.
Yeah, well, now you may be like, what if I want to use a more complex API and then I need to port all those interfaces? And here are actual things from the Python standard library. We're working on a generator that can turn Python APIs into Java APIs, and that you can use easily. We may even ship those for the Python standard library, for example, so you don't need like the ones from the Python standard library, but just for the ones that you like, the custom packages that you want to use. Right. Shall we go back to the slides?
Right. Yeah. So let's talk a little bit now about the architecture behind these things, right? So as I said earlier on, all of these projects, GraalPython, JavaScript, and GraalVM, are running on any OpenJDK. They are written in pure Java code. So they are written in pure Java code. They are optimized by the GraalVM JIT compiler. And what's new since the last release is that they are production ready. So the only thing you need in order to run these languages embedded in your Java application is that you need to be on Java 21 or later. So this is the baseline requirement from a Java version perspective. And now you could think again about what's the pro and cons, what problem does this all solve? Like currently, I think it's evident that in a larger complex system, you might want to use maybe different languages or different libraries. But currently, the current setup that you would have to go for without using this technology is, well, you need to have a microservice setup where you have a Java service talking to the Python service. You would have to transmit the data over the network to your Python program that turns then the PyGraal library, and you would have to transmit the SVG back. So you would have to set this up in this way. And with this technology, you can run all of it in the same process and in the same server.
And you don't need to synchronize the data, right? You don't need to allocate data multiple times.
You don't need to define a REST API, for example, right? So there's no pros and cons of these two approaches. Now the pro of putting everything together is that, well, if it's in one process, it's in one managed heap. So there is one Java garbage collector that's collecting here the Python objects and the Java objects together. This means no data overhead. This means also no memory overhead configuring two different runtimes with two different heap sizes, for example. You have a very low overhead on the calls, of course, and data can be shared. Now, the disadvantage of doing it this way is that you are limited to the runtimes that are available to you from these projects, because you can no longer mix and match certain versions. Like when we provide a runtime, we currently support Python 3.11, you will have to stick with that runtime. And you can no longer mix and match here a very different Python runtime with your Java runtime. But if that limitation is not a problem for your deployment and you're happy with the set of libraries and support that's there, then the setup and the deployment is going to be much easier. Also, the deployment as such, it's much easier to deploy just one application than deploying many different ones and then scaling them differently and so on. It's also very interesting for companies that are, for example, heavy Spring users or heavy users of Micronaut or Quarkus, because they might have some base libraries in Java that each of their services wants to use. And then having the option from that base library to call out to Python can be interesting. And we're working currently with all of these framework vendors. Micronaut already has the integration with PyGraal, but we're working now also with Spring and Quarkus to such they have extensions and plugins for these integrations. Now the deployment options are that, well, you can just deploy everything as a JIT application, where you use JIT compilation for Java and Python. In this case, everything gets put into a fat jar, also the Python resources, and you just distribute this jar file together with your JDK. Now on the right, we see here for a typical Micronaut demo using Micronaut and GraalPy together, it means that the jar file size is about 170 megabytes. That's of course larger than your typical Java application because the Python runtime needs to be included. Now you can choose to still create a native image out of your Java application. And in this case, everything gets put into one executable. That's also something that can be interesting for deployment because suddenly your whole Python environment and your whole Java environment is captured in a single executable file that you can deploy anywhere. And in this scenario, you have two choices. You can either still include a JIT compiler for Python in your native image. It gets a little bit larger then, but it will have better peak performance for Python. Or you can choose to go use the Python only in interpreter only mode. And in this case, the deployment gets a little bit smaller because you don't need the JIT compiler. Now, Python and Java are very different languages that have different characteristics, specifically with respect to threading. Same also with JavaScript and to a certain extent also WebAssembly. So one thing you need to be aware of is that if you use this type of embedding, then you cannot run the Python multi-threaded. So if you use a single Python context from multiple threads in Java, they will block on entry because the Python has to run single-threaded. And if you want to still have multi-threaded performance, you will have to use multiple Python contexts. And in this way, do some kind of pooling to make sure that your application is still running multi-threaded. But yeah, so this is one of the major architectural differences that you need to be aware of when you combine these two systems. All right, so let's go to the second part of the demos.
Okay.
Let's get a little bit more involved.
We start with JBang. So here's a little JBang script.
Yeah, so JBang, who doesn't know what JBang is? Everybody knows what JBang is. Very good, very good, very good, very good. I love JBang. And so maybe let's show the code of this.
Well, maybe let's run it first. This is the URL to the repository, by the way, with guides and demos. If you want a quick link, here is one at your convenience, right? And this was generated using a Python QR code package. And it's all done in this QR code Java file, right? So I'm sorry, I have to take this away, but we show the QR code again, right? Maybe I can leave that here. But like these are the dependencies that are usually behind the POM that you've seen earlier. And then there's this magic thing that you can specify pip dependencies, in this case QR code. That's the package. From here we do argument parsing, we create a GraalPy context, right? And then we get the QR code module and we wrap it as the QR code module, which is Java interfaces, right? And from here we continue and do what the example actually does. This is the example on the website. This is the Python code, and the Java code is very close to that. And then the result is some Java string, and we print that to the terminal, right? So that's how this works. Really simple.
Yeah, so almost the same set of code, and you can specify again here in JBang multiple language dependencies on any Python package and on any Java package.
Right. So there's one thing that we haven't talked about so far. Well, it's cool that you can leverage other packages from other language ecosystems, but our languages can also be used to provide scripting capabilities in your Java application. So let's say your customer comes and says, oh, I want to be able to customize your application, but my developers, they only speak Python, they only speak JavaScript, right? We don't want your Java application for some reason. And you can do that with these, with our languages. So let me show you an example. Here is a domain object, a book. Right? So let's say this is my domain object, a book, has different fields, all of the fields are private. Then there are some getters and some setters, and these are public, but we don't have setters and getters for all of the fields, right? And then there's a book repository. Well, no need for a database here. This is just an array list of books. But this is my database, my repository of books, and they're all predefined. So let's say I have a Java application, I want to expose this to my users, right? So I've written a little AWT application, or Swing application actually, that I can run here. And here it is. So what I can do is I can interact with the books repository. So I can, for example, get the last book, which is the Chronicle of Narnia. Yep, that looks all right. And I can also interact with the object, but of course in Python, right? So if I get the last book and I can ask it, what do you understand? It will actually give me the interface, the public interface of the Java object, right? So I can configure this and I can make it explicit or implicit, and I can take it from here and provide convenience functions. For example, I can provide an add book convenience function in Python so that the Python users are not exposed to like the Java way of doing things, right? So I can run that, and that returns like a new book, which is a Java object. It's a new Java object, and if I look at all my books, The Hobbit is now the last book in the list, right? So that works. So there's another aspect to this. Well, now you may be wondering, what if my users are doing something evil, right? Like they import sys and they try to exit the process. So let's try to do that. Oh, didn't work. Nice try. You cannot shut down the process from Python. Right? So you're in control of what you want to like expose to the user. And you can also say, you can make restrictions and say no file access, no shutting down processes, no talking to the internet, right? Yeah, let's take this one more level up. So there's also window. Yeah, it's a syntax error, a backslash. But this window object is a JFrame object, right? So and in case you're wondering how this works, we can take a quick look. So here is the JFrame in my run, and here's the context that I've created. Then, I pre-initialize Python, and I get this bindings object. This is the more or less global scope for Python. And then I put in my books Java class, my books repository, and the frame object, and I call this window, right? So why would I do that? Well, because I can. And because I can do like get title, and it will say Java console, right? So I can do set title, and I can do hello devox, right?
So you're escaping the sandbox.
Well, because I've allowed to do this, right? Because I put the window object into this bindings, made it accessible, right? So now I've changed the title of this window, right? And because, I also like Python from time to time, and I couldn't resist. I wrote like a little animate function in Python, right? And if I want to show you how that works, let me get this out of the way, right? That's also written in Python. Just a really simple loop, right? That messes with the window location. Nothing special. But again, I get auto-completion. It doesn't know that this book exists, right? Because there's something that we have injected.
Yeah, so you're going to file a feature request for IntelliJ.
Maybe there's still some room for improvement, but this works pretty well. And if you want to take this for a spin, it's also in the repository. Okay. We've also been talking about more languages, JavaScript and WebAssembly, and I've run the JavaScript example, but I actually want to show you a WebAssembly demo too. Right? So here is a library called Photon, which is written in Rust, and it can be compiled to WebAssembly. And as such, you can, I think there's a demo link here, you view demos, and that takes you to this page. And you can apply different filters to the image, right? You can flip it vertically, for example. And this all runs in your browser using JavaScript and WebAssembly. And right now, WebAssembly is a bit awkward if you want to parse complex data structures. So what they do is they generate JavaScript wrappers to do all of this, and that works nicely in your browsers. But what if you want to use this in a microservice framework, for example, right? So we can do this. We have JavaScript at our disposal, thank you, and WebAssembly at our disposal.
Not getting disposed.
Yeah, not getting disposed. So, and here it is. Here's a simple service that serves an image, and the default filter does nothing. So I can change it to, let's say, grayscale, and I get a grayscale version of this, or I can change it to flip V, and that flips the image, right? So not too fancy, but maybe let's take a quick look at what the implementation looks like. So here's the Photon demo controller, which implements the Photon endpoint. And this this provides an effect name. And from here, I'm going into a Photon service, which provides this process image. And process image method takes the effect name, and here comes something into play that Thomas briefly mentioned. We're actually pooling Photon contexts. So for because these requests are handled in parallel potentially, we want to respond to them as quick as possible, right? So what we do is we have created a Photon pool, and we take a Photon instance of that pool, and then we use this Photon instance, ask it, do you implement the effect? If not, then not found, right? And if you do, then create our demo image, which is a Java byte based on a Java byte array. It creates that, turns that into WASM WASM memory through the JavaScript wrappers. Then we apply the effect with the effect name on that image, and we ask for the byte array representation of the byte array of the image again. And because this is Rust and like this is all new, like we need to free it, which is a bit unfortunate, but And then we return the result, and we release the Photon object back into the pool for the next thread, right? So, and this is really fast. Like we can get really close to V8 speed, right? So you can run this in parallel, and I think our measurements on like the latest version that we have is something like 50 milliseconds for a request. Whereas in the browser it takes something like 15, 20 milliseconds per request. So there is some overhead, and we are just starting to optimize this even more. But we're not too far away from what the browser performance is like. And I think this is super exciting, right? So you can build complex applications. You can turn image processing libraries, image recognition libraries, you name it, everything that you can compile to WebAssembly and run it in your Java process. Okay, back to the slides.
Yes, you can also compile Doom to WebAssembly and run it in the...
Yes, that's
gonna be
not another Doom demo.
Yeah. We had enough demos.
Yeah.
It's good. So this all, as we showed, if you have a nice library somewhere that you like from one of the other language ecosystems, you can use it and conveniently so. Now the question is, what about my favorite Python package? Will it work or will it not work? Now, in general, we have support for a very large portion of Python packages, and we are adding more over time. Now, one challenge with Python for our Python support is actually that, well, when you run Python, typically you don't run much Python, but you run a little bit of Python on a lot of C++ and native code. And that's why for compatibility, it was very important for us to also support native extensions. And we do support native extensions. They do work. Now there is one thing with it is that you do need to recompile them for GraalPy. So when you have a Python package with native extensions, it needs to be recompiled. Now we are working on something where we would recompile for you the most popular Python packages and put the recompiled version on Maven Central. So we are waiting also for community feedback here on what packages you are most interested in and what should we focus on when we are deploying and distributing those packages to you. Because it should be as simple as adding a Maven dependency to use a Python package, and we don't want that this have to be recompiled by the user.
Well, in the normal Python world, you would download a precompiled NumPy, right? And the native extension is actually compiled and tied to CPython, the standard Python interpreter. So we need to recompile it and then ship it. And we've done this already by providing a GraalPy PyPI repository that GraalPy already uses under the hood, right? But a couple of more notes on compatibility, maybe.
Yeah, so in terms of compatibility, we are currently based on Python 3.11. 3.12 is in the works as we speak. We have a very easy upgrade path from JSON. So if your application is using JSON, there's a guide on how you can migrate to GraalPy. And GraalPy is certainly much more compatible with the latest Python standards than JSON. So we definitely would recommend us as a drop-in replacement for JSON. We have, on our website, we have database where we show the compatibility with the top 500 Python packages. We are using internal testing where we test the top 500 packages and we publish the results on this website. So you can look up whether the package you want to use is already tested by our team or whether there is already known issues for it. And as I mentioned earlier, if you run into issues, if you tell us, it's good for my team to understand what kind of packages you would want to have prioritized. And so if you run into issues with a Python package, definitely file an issue on GitHub or let us know on the community Slack. And Python extensions need to be, native extensions need to be built from source. But we are starting our own Python repo as well, and such that you can download them directly from there. Yeah, so with those three things, GraalPy, GraalJS, and GraalWasm, to summarize, we give Java developers the power to use other language ecosystems. It's really easy to integrate. You only have to put a Maven dependency or a Gradle dependency for your project. The projects are self-contained, run on any OpenJDK. We, of course, love it if you run it on GraalVM, and we think you should definitely use GraalVM to run it, but you don't have to. So if you are on another OpenJDK distribution, you can absolutely use them. The languages will be interpreted, but in many scenarios, for example, when you have this scenario where you use a Python library, typically the performance-intensive parts are anyway written in C++C, so that the Python is interpreted shouldn't matter for your peak performance, and your warm-up will be similar, or even better if you go to only in Jupyter only. We are working with large Java frameworks to provide even more convenient integrations. There is an existing integration in Micronaut. You can look up the guide there. And we are working with Spring and Quarkus on that. And it's ready for production right now. Now, JavaScript and WebAssembly, they have a better specification of their language and platform. So there we are very, very compatible, like comparable to any other engine out there. If you compare us in JavaScript compatibility, even with Firefox, SpiderMonkey, or V8 from Google, we are in a very similar category with respect to JavaScript and WebAssembly compatibility. Now for Python, we still have challenges with native extensions because Python doesn't have such a nice mechanism like Java, which is GNI. And so therefore the Python native extension interface is very challenging for us to get 100% right. But we have a team constantly improving that. And we have tested it very intensely on a large set of Python packages, and it should be also ready for production. But if you run into issues with specific Python packages, or you want us to work on specific Python packages, please let us know about that. Yeah, so all of the demos and guides that Fabio demonstrated in this talk here are available on GitHub. This is the URL. You can download it, you can run it. You should be able to run everything and replicate everything we showed in this talk.
And there's more, of course.
Right? Yeah, there's actually more.
There's actually more.
We showed a subset, right?
Yeah. Yeah, and use the QR code thing to generate the QR code here.
Yes.
Dog food your own stuff.
That's right. That's
much
right.
as you can.
Yeah. There's even more demos there than we showed today, but you can download it, should run everything, and this way you can start experimenting with this type of technology.
Yeah, and we are continuing to add more demos and guides currently on a weekly basis. So one thing that you may be wondering is like, how do I debug my Python code in my Java app, right? So that's also something that's surprisingly easy. And especially thanks again to the JetBang folks for building a cool IDE that integrates with Chrome Inspector, for example. You can debug your Python code within IntelliJ. We'll publish a demo on this too.
Mm-hmm. Yeah, and so in general, this technology is certainly very new and very different from what was previously possible. So we are looking for folks like you who have business applications, who are users of this type of technologies, to help us with feedback and to be maybe try it a little bit, be some early adopter, and help us guide this further. Because like nowadays, GraalVM is mostly used for native images, or known for native images. But if some people still remember the very original dream of the project, it was the dream of polyglot, and we haven't given up on the dream yet. And we think with this approach that we currently have here, with a much better integration with build tooling, IDE integration in collaboration with the IntelliJ folks, and the focus on Python, JavaScript, and WebAssembly, we think that we might be now at the point where also this part of GraalVM will be useful for people in practice, and we'll be very happy to see that. So thank you for your attention, and we have a few minutes for taking questions. Thank you. I didn't quite get the question. Did you guys?
Well, the question was, what about GraalC, so that we don't even need to compile anything, and you can just interpret C code. So the
GraalC.
Yeah, so
okay, got it.
Yeah.
Yes.
Not Graal compiler, Graal C capital
Yeah. I think
Yes.
someone has actually
Yes.
built a compiler in Truffle for C. I'm not sure.
You mean
We
running
need to
C
check.
code on Graal, right?
Yeah.
Yeah. So we have a project that is interpreting C code on top of Truffle. It's called Sulong. Now we are currently not using the project in that context because of the memory footprint and warm-up issues that we ran into when we tried that. Because the C code, it works well if the C code is relatively small, but for a lot of the packages, of Python packages, sometimes the C code is humongous. So if you, for example, look at the C code behind the TensorFlow Python package, I think it's 1 million or more. And so the C, there's almost no alternative to really ahead of time compiling that C code. And
Well, in that setup, it didn't make much sense because, as Thomas mentioned earlier, the Python community rewrites everything in C++ and C to speed things up, so the performance critical things are in C and C++. And if that is slower because it's interpreted, still JIT compiled but interpreted, right? Then you're losing some of that performance benefit. You're gaining like memory safety and whatnot, but yeah, the Python users don't really care about that too much, you know. So native performance was more important. You can still compile and run LLVM bitcode in managed mode essentially. That is still working, and I think even used in production somewhere.
Yes, it is used specifically for security reasons. So one of the features that we have on the platform is that if you have a very high security requirement, we can actually run your C code in this managed and sandboxed form, right? And that's in general for this whole embedding scenarios, also the one that Fabio showed with this book and JFrame window example. The main use case there is like when I want a secure sandboxed environment where I have a base Java application, that's the framework, and then in the secure sandboxed environment, you're executing these languages. And this type of scenario is used quite often at different larger enterprises. It's used also at Amazon, for example. It's used at Oracle, embedded in the Oracle database. So this type of embeddings is a corner use case that's already in production for many, many years in different scenarios. And there we provide like some sandboxing, some security, some safety around that. Whatever is running inside should not break out of that sandbox. And in that scenario, C can also be interesting if you don't trust your C code. For example, the OpenSSL heartbleed bug that was caused by a memory corruption in OpenSSL code. Such a bug could not happen in the way we are executing the C code.
More questions?
Okay. My question is about testing pieces of code, because you have Python embedded. Why would you advise to test that embedded code in your Java? So
Yeah.
do you advise to test it in Python side, or how can you test it in Java?
Yes, so the question is, how do I test my embedded Python code? Right, so as a Java developer, you want to do as much as possible in Java, right? So the tests that are accommodating some of the demos are just all JUnit tests, right? Because all the craziness is hidden behind the Java interfaces, which are then representing the actual Python objects. So I think that's probably the way you would want to go. But of course, no one keeps you from using something like PyTest to write your Python test for Python critical stuff. So I would say at the end of the day, it depends on how much code do you write on the Python side that you may want to test with a Python testing framework, and how much code do you write on the Java side, and like what framework do you prefer? What testing framework do you prefer?
Right. Yeah, but you have options for both. Yeah.
Yes.
And yeah. So if you have more in-depth questions, we will have a session on Thursday evening in a smaller room where we will talk about the future of GraalVM, and we will also cover some of our thinking about the future strategic direction of this area. So if you're interested in that, really feel encouraged to join us on Thursday evening. It's at the same time as the closing keynote ceremony. And if you want to hear more about AI and GraalVM, of course, you have content for this as well, which is tomorrow. Alina and Alfonso will talk about how we're not calling out to the OpenAI API anymore, but we are directly executing the LLM inference on top of GraalVM native image. If you're interested in that, join Alina and Alfonso tomorrow. And yeah, give us feedback on the session and on the voting for the session, and give us feedback if you liked it. And with this, I would like to thank everybody for your attention.
We're still
Thanks
around.
for coming, still around, and thank you very much.
All systems are nominal. Initialize Genesis